Right. I sent some questions in the group. Let's solve those questions first. We're going to a more difficult problem. All right. There are some questions. Four questions I've sent in the group. Did you all receive the questions? Students, have you received the questions?
Yes, sir.
All right. Okay. So the first question says you got a block. Mass is not mentioned. Note: mass is not mentioned. Initial velocity of the block is given. Coefficient of friction is given. Angle of inclination is given. Of the incline. All right. So what do I do? I need acceleration for that. He is asking what distance will it stop? Distance traveled by the block on incline before it stops. All right. So for acceleration, I need force, for which I need FBD. So FBD of the block is normal reaction, mg cos theta, mg sin theta, because velocity is in upward direction of the plane. Kinetic friction acts down the plane, which is mu times n. Right. So net force would be mg sin theta plus mu mg cos theta is equal to mass times acceleration. M gets cancelled out. A is equal to g times of sin theta plus mu cos theta. So that's my acceleration. Mass is getting cancelled out. Look at this. Let's say mass is not mentioned. If at all in such cases, whenever mass is not mentioned, you presume the mass to be m and go ahead with the calculation. Go ahead with the procedure. So if mass gets cancelled out, if mass is not mentioned, it will get cancelled out. All right. And that's what you observed in derivation as well. It is independent of the mass. Acceleration of the particle is independent of the mass. It only depends on the angle and also the coefficient of friction mu. And coefficient of friction given as half. What is tan 37, students? So he's asking what is the distance traveled before the particle before the block stops. Once I get the acceleration, A is equal to sine 37. What is sine 37? Here is a triangle 3, 4, and 5. This is 37 degrees. Sine 37 is 3 by 5 plus mu is 1 by 2. Cos is 4 by 5. So 2, 2. Can you tell me what the acceleration now is? 3 by 5 plus 1 by 2 times 4 by 5. How much is it, students? Find out this acceleration. Let me know the acceleration. I'll give you a minute. 30 seconds are enough. So we have Ashita, Hashini, Likita, and there's another student. I don't see the name. All right, Likita says G. Great. That's perfect, yeah? That's perfect, Likita. That's G. So I'll get G downwards. So it's not acceleration, it's not falling under gravity. So it is the acceleration produced because of gravitational force and frictional force, all right, which is G. Now, which is, let's say G is 10 and V naught is equal to 10 and A naught is equal to G downwards. So particle will retard because particle retards, it will eventually go and stop at some point. He's asking what distance will it travel before it stops. So the equation which I'll use is V square minus U square is 2as. V square minus V naught square is equal to 2as. Final velocity is 0 minus V naught square is equal to 2 times minus G times S. Minus gets cancelled out. So V naught square by 2G, which is 10 times 10 by 2 into 10, 5 meters. Is it correct? Please just check. Or you just let me know what the value of V square by 2G is. What is the value of V square by 2, V naught square by 2G? Substitute V naught as 10. Yeah, V naught as 10 meters per second. And G we got as, sorry, G is 10. A we got as G. Retardation is G. And the value of G I'm taking it as 10. So let me know what the value of S, which is V square by 2G, V naught square by 2G. That's the distance after which distance traveled by the particle before it stops. But once it stops, does it come back is the question. You first let me know what's the value of this S, V naught square by 2G.
5, sir.
All right. Yeah, that's right. It's 5. So 5 meters is the distance it travels. Now, once it stops, does it come back? How do I know whether it comes back or not? If this angle is less than angle of repose, it doesn't come back. If this angle is greater than angle of repose, it will come back. Right? If this angle is less than or equal to angle of repose, it doesn't come back, it just stays there. But if this angle is greater than angle of repose, it will slide back. How do I find angle of repose? Tan inverse mu. So tan inverse half. What is tan 37? 3 by 4. And tan theta is tan inverse tan theta is 1 by 2. So tan inverse of this one, tan inverse of this one. Now, which is 0.5 greater than 3 by 4? How much is 3 by 4, students? 0.75. So this angle is greater than this angle. That means this angle is greater than angle of repose. So it will definitely slide back and will not stop again. But it will come down with a different acceleration. It will come down with an acceleration of g times of sine theta minus mu cos theta. All right, that's what you have observed. Last time we get plus while going up and minus while coming down, independent of mass. All right, great. So let's go for the next question. She is given a situation where a force is applied on the block. Angle is again 37 degrees. Mass is 10 kg given. A force of 75 Newton is applied up the plane on the block in the direction upward parallel to the plane. All right. And mu is 0.05. Is it 0.05? Yes. All right. Let's look at the procedure now. The question is calculate the force of friction acting within the block an incline. Block is initially at rest. Calculate the acceleration of the block. Assume the block is initially at rest. Calculate the force of friction acting between the block and the incline. All right. Look at the students. To find the acceleration, I need to find whether first the block is net force on the block is beating limiting friction or not. If it beats limiting friction, particles start accelerating. If it doesn't beat limiting friction, my friction will self-adjust to itself so as to counterbalance the external force. All right. So I've got 75 up the plane. FBD would be 75 up the plane. Normal reaction this way. NG cos 37. This way, which is 80. 60 Newton down the plane. 75 Newton up the plane. And this is not 0.05 students, it's 0.5. Okay, that's a misprint. Mu is 0.5 there. So limiting friction is, see, look at this. Whenever you have to decide static friction, whether, see, it's at rest initially. So friction is going to be static itself. It's not going to be kinetic. If there is relative motion, it will be kinetic. But because it's at rest, I'll presume the surface is smooth. And I'll see in which direction is the body tending to move. If the surface is smooth, 75 is beating 60, so it will tend to move up the plane. Friction will act down the plane. All right, I'll presume it is smooth. I'll find the direction in which it is tending to move. How will I find that? I'll find the direction of net force. Direction of net force is upward because 75 is beating 60. 75 minus 60 is upward, 15 Newton upward. So friction has to act down the plane. But now my limiting value of the friction is mu times n, which is half times 80, which is 40. FL is 40. Limiting is 40 students. Friction is not 40 because limiting is 40, but required is only 15. For me to counterbalance the external force, required friction self-adjusted value is 15. So because 75 is equal to 60 plus friction, friction is equal to 75 minus 60, which is equal to 15. So my friction is 15 Newton on the block and the acceleration of the block is 0. Do you all get this, students? Problem is not complete yet, but this part of the problem is done. So do you all get this part of the problem?
Yes, sir.
All right. All right. Now, I have to find out, second part of the question is find out the additional force required for the particle to move up the plane. So for it to move up the plane, my friction should reach the limiting value of 40. So net force down the plane will be 60 plus 40, 100. Let that additional force be x or fx. So I'll have fx plus 75 is equal to 60 plus 40. So fx is equal to 100 minus 75, which is 25 Newton. Do you all get this? He says calculate the force, calculate the additional force, which is excess of 75 Newton, for which the block starts to move up the incline. For it to move up the incline, friction will be down the incline, which should reach the limiting value. And limiting value is mu times n. Mu is half. Half times n is half times 80, which is 40. So limiting value is 40. Net downward force is 60 plus 40. Upward force should be fx plus 75. For it to move up the plane, friction acts down the plane, which is limiting value. So f plus 75 should be equal to 60 plus 40. Fx plus 75 should be equal to 60 plus 40. Fx is equal to 25. Is that okay? Now look at the third part of the question. He says find the minimum force such that The block does not move at all. Find the minimum force that can replace 75 newtons so that the block does not move. ఇప్పుడు 75 న్యూటన్ తీసేసి ఇంకొక ఫోర్స్ యాక్ట్ చేస్తుంది. Now when that force is acting, I have to determine the force, minimum force, not the maximum force. Minimum force. See, there's a difference. చూడండి ఏమవుతుంది, ఏం అప్లై చేయకుంటే that will try to slide down, friction will be upwards, and friction limiting would be downward force is 60, friction limiting is 40. So excess force should be x is equal to 20. If I go on increasing this force x, this 40 will self-adjust, become 0, then reverse. If I go on increasing x, that means minimum is 20, maximum would be x is equal to 60 plus 40, x is 100. So between 20 and 100, the block doesn't move. When x is equal to 20, force is 20, applied force is 20 Newton, the block will tend to move downward. When the force is 100 Newton, the block will tend to move upward. But between 20 and 100 Newton, the block doesn't move at all. All right. So whenever static friction comes into picture, you will have to understand that there is a range of friction for which the range of values of the applied force for which the block doesn't move. And how do I find that range? When I apply minimum force, block tends to slip downward. When I apply the maximum force, block tends to slip upward. So between these two, maximum and minimum, block remains there, and the friction will self-adjust from 40 upwards to 40 downwards. 40 upward ఉంటుంది limiting, సెల్ఫ్ అడ్జస్ట్ అయ్యి 0 అవుతుంది. 0 అయిన తర్వాత డైరెక్షన్ చేంజ్ అయ్యి మళ్ళీ కిందకి 40 అవుతుంది, ఇంక్రీజ్ అవుతూ 40 అవుతుంది. Is it clear, students? Is this part of the question clear? This part of the question is interesting. Alright, కావాలంటే మళ్ళీ చెప్తాను, but is that clear? అందరికి
Yes, sir.
okay?
Yes, sir.
All right, okay. But still, I'll just repeat. చూడండి, I've got a force x upwards. If I don't apply any force, block will tend to slip downward because limiting is 40, external force down the plane is 60. So it will tend to slip downward. For it to stop, for me to stop the block from slipping, I have to apply an additional force of x is equal to 20 upward. If I go on increasing this force 20 to 30, my friction will self-adjust now. If I make this 30, friction becomes 30. If I make this 40, friction becomes 20. 50, 10. 60, 0. Friction becomes 0. 70, friction will reverse. 75, friction is reversed. 80, 90, and 100, that time 60 and limiting value of friction is reached in opposite direction, down the plane. If the force is 101 now, it will start moving upward. So between 20 and 100, the block doesn't move. In this case, block tends to move downward. In this case, 100. In the case of 100, block tends to move upward. All right. Okay, look at the next one. The coefficient of friction between the block is mu. Between the blocks is mu. Find the magnitude of the horizontal force F required to keep the block stationary with respect to wedge. All right, with respect to wedge, stationary undali. But why does it remain stationary is first you have to think. Friction వస్తుంది మధ్యలో. Friction వచ్చాక friction will counterbalance the gravitational force, because of which it will remain stationary with respect to the wedge. కానీ అది స్టేషనరీ ఉండడానికి కారణం ఏంటి? If I do it, if I solve the problem, first I will choose a reference frame. If I choose a reference frame to be my moving block, M, capital M, then I'll have a pseudo force acting on the smaller block. M, M. So if I stand on this block, and draw the FBD of the smaller block, I've got normal reaction, pseudo force, which is small m times A, where A is the acceleration of the system of the reference frame, mg, friction. And friction, limiting value of the friction is mu times n. So for it not to move, for it not to slip downward, mg should be mg should be less than or equal to mu times n. And what is the value of n with respect to this frame? My FBD is this, and acceleration is 0. So FBD and MED is complete. What is the acceleration now? 0 with respect to this frame, because it is at rest with respect to the bigger block. Smaller block is at rest with respect to the bigger block. All right, this is the wedge. This m small m is at rest with respect to the wedge. That means acceleration of the particle of block small m is 0 with respect to capital M. So MED is complete, FBD is complete. I've got 3 real forces and 1 pseudo force. Why is pseudo force coming into picture? Because I'm solving the problem with respect to a non-inertial reference frame, which is an accelerated reference frame. Non-inertial reference frame means accelerated reference frame. When I solve the problem using in this kind of reference frame, non-inertial reference frame, a pseudo force comes into picture, which is mass times acceleration and directed opposite to the direction of acceleration of the reference frame. Acceleration of the reference frame is towards right, MA is towards left, pseudo force is towards left, and here F is acting. So N is equal to mass times acceleration. M gets cancelled out, so A is greater than or equal to G by mu. Right, now he's asking force required. I got the acceleration required, but if I see the force required for the combined system, acceleration is A, F is equal to mass times acceleration, so M plus M into A. F is equal to capital M plus small m into A, which is G by mu. That's the answer. But is he asking minimum or maximum? No, there is only one force. But F greater than this one, the block will surely be at rest. F less than this one, the block will start slipping. F equal to this one, it will tend to slip downward. All right. So there is again a range of values of F for which the block is stationary, but you only have a minimum value beyond which if the F is more than that minimum value, block is definitely at rest with respect to the wedge. All right. Did you all follow what I meant? I've drawn the FBD of the M, choosing reference frame as non-shell reference frame. Either ground frame to chedamu in 2 minutes. But once I choose the reference frame, then draw the FBD in that reference frame. Because I've chosen non-shell reference frame, I've got 3 real forces. In addition to that, I've got a pseudo force. And acceleration of the small block with respect to the wedge is 0. So MAD and FBD is complete in this diagram. A is equal to 0. Or AX is equal to 0. A relative is 0. All right. And A over there is acceleration of the complete system, which is moving together. M plus M is moving together as a single block, like this. So I don't have to treat them separately. So I've got mg should be equal to F or less than or equal to F for it not to move. And n should be equal to ma, because n minus ma equal to 0 in horizontal direction. So n is equal to ma. I substitute n over here. I'll get mg is less than or equal to mu times ma. M gets cancelled out. A is greater than or equal to g by mu. This a I substitute over here. F is equal to mass times acceleration. All right, that's how I get force required. So F should be greater than or equal to this force for the particle to be at rest with respect to the wedge. So minimum force is m plus m into g by k. And anything more than that, block will remain at rest. But what will be the value of friction on the block? What is the value of friction on the block, students? When is it at rest? Is it mu n? No, limiting value is mu n. Friction is equal to the external force. I presume the surface to be smooth. If the surface is smooth, it tends to slip downward. Friction will act upwards. And how much will be the friction? Because it is less than the limiting, my friction is self-adjust so as to counterbalance external force, which is mg. So friction is equal to mg. Particle is at rest, net force should be 0. Vertical force acting is only mg and friction. So friction should counterbalance mg. That means friction should be equal to mg. So friction is mg as long as the particle is at rest. But limiting is not mg. Limiting is mu into ma. If this force is decreased, this limiting decreases. If this limiting decreases and becomes lesser than mg, the block will start sliding down. All right. Now let's do the same problem with respect to ground frame. In ground frame, you'll have all the forces, real forces. You will not have a pseudo force, and your MAD will be different. Your mass acceleration diagram will be different. So acceleration will be different. So I've got small block m, small m, normal reaction, mg, friction, and acceleration is a towards right. Right, this with respect to ground frame. So look at this. I don't have a pseudo force now, but my MAD has changed. So equations again will turn out to be the same mathematically. N is equal to mass times acceleration. Previously, I had n minus ma equal to 0. Both are same mathematically, but physically they are different. Here it means equilibrium, here it means force and effect, cause and acceleration, cause and effect. Here it means the particle is at rest, but here it means the particle is moving with an acceleration a. Alright, they are mathematically same but physically different. This is what I've been insisting every time, and that's very important point. So I have n is equal to mass times acceleration. Limiting friction is mu times n, which is mu times ma. If this is greater than or equal to mg, I'll get acceleration. M gets cancelled out. A is greater than or equal to g by k. I got acceleration. Now, if I consider this block together as one system, F is being applied like this. So F is equal to m plus m into A, which is g by k. G by mu, sorry. So I get the force as this much. So from ground frame, I did the same thing, except I didn't apply any pseudo force. I got the same result. Obviously, because change of frame should not change your result. All right, physics doesn't change if you change your reference frame. Mathematically, equations do alter, but your physics remains the same. Here, I don't have a pseudo force, but my MAD is different. So I have an equation n is responsible for the mass times acceleration. So with respect to ground, I see the particle going towards right with an acceleration a. But with respect to the wedge, I see the particle to be remaining there itself at rest. But with respect to ground, the particle is going towards right with an acceleration a. So n is responsible for a. So n is equal to ma. Vertically, there is no motion because you said particle is at rest with respect to the wedge. So FL should be, which is mu m a, should be greater than or equal to mg. Limiting force should be greater than or equal to the external force on the block. All right. Yeah, is it okay, students?
Yes, sir.
A doubt na adagandi. All right, don't hesitate. మీరు మళ్ళీ అడిగినా మళ్ళీ చెప్తాను. I've got immense patience to repeat n number of times. All right. All right. I'll go for the next one. So what is happening here? Can someone tell me what is happening here? In this question, what is happening, students? He says there's a force which is applied 20 Newton perpendicular to the wall, and there's yet another force which is a 10 Newton applied parallel to the wall. And I have to determine whether the block will move or not. And if it moves, in which direction does it move? So one force to have this block, one force is this one, 20 Newton. The other force is 10 Newton parallel to the wall. All right. So one force is applied is 20 Newton. Gravitational force acting downward. Friction is acting upward, obviously upward. Why do I say upward? Asha, tell me, is the friction upward or downward? It's upward, but can you tell me the reason why it's upward? See, I presume it to be frictionless. It is stripped down. If it is frictionless stripped down, it will have a tendency to go downwards. So friction will act upwards. That's how we decide static friction, right? Kinetic friction, if there is relative motion, friction is opposite to the direction of relative velocity. But if it's static friction, I'll presume the surface is to be smooth. And I'll see in which direction the block tending to move. If it is tending to move towards right, friction will be towards the left. If it is tending to move downward, friction will be upward. So in this case, it will tend to move downward, friction will be upward. Now the question is, if I apply another force of 10 Newton here, will the block move? So I've got a force of 20 Newton into the plane. mg acting 1g. One force applied 10 Newton. This 1g I'll write as 10 Newton itself. So result net force applied is 10 root 2 Newton. So it will have a tendency to move in this direction if the surface were smooth. So friction will act in this direction. Now, how much friction will act? I have to determine the limiting value of the friction. What is the limiting value of the friction? Mu times n. What is normal reaction? I am pressing it with 20 Newton. Normal reaction will be 20 Newton. So mu times n. What is mu here? 1 by 4. So 1 by 4 times 20 is 5 Newton. So limiting value is 5, but external applied is 10 root 2, which is greater than 5. So block will definitely move along this direction with some acceleration a. And what will the acceleration of the block be? 10 root 2 minus 5 by mass. 10 root 2 minus 5 by 1, which is 5 times 1 plus 2 root 2. 2 root 2 minus 1. All right, I'll come to that again. But have you understood the scenario, students?
Yes, sir.
10g 1g down కింద యాక్ట్ అవుతుంది, ఇది గ్రావిటేషన్ ఫోర్స్. 10 న్యూటన్ ఇలా అప్లై చేశారు ప్యారల్ టు ద ప్లేన్, హారిజాంటల్లీ ప్యారల్ టు ద ప్లేన్. హారిజాంటల్ ఫోర్స్ 10 న్యూటన్ ప్యారల్ టు ద ప్లేన్. చూడండి 20 న్యూటన్ కూడా హారిజాంటల్ ఫోర్స్ బట్ పర్పెండిక్యులర్ టు ద ప్లేన్. ఈ సేస్ ప్యారల్ టు ద ప్లేన్. సో ప్యారల్ టు ద ప్లేన్ అంటే ఇది ప్లేన్, అంటే ప్యారల్ టు ద ప్లేన్ ఇస్ దిస్ వే. ఇన్ హారిజాంటల్ ఇది కూడా ప్యారల్, ఇది కూడా ప్యారల్, ఇది కూడా ప్యారల్, అన్ని ప్యారల్. బట్ దిస్ ఇస్ హారిజాంటల్ ఫోర్స్ ప్యారల్ టు ద ప్లేన్. సో 10 న్యూటన్ రైట్ వర్డ్, 10 న్యూటన్ డౌన్ వర్డ్, Resultant of these two is 10 root 2 Newton this way. Right? I told you whether I should show the resultant or the components. So I'm showing the resultant. I'll erase the components. So resultant is 10 root 2. If the surface were smooth, the body would move in this direction. So body has a tendency to slip in this direction, and the direction at an angle of 45 degrees with the horizontal. Why is it 45? 10 and 10. Resultant is angle bisector, which is 45 degrees with the horizontal. So friction will act this direction, in this direction, opposite to the direction which it tends to move. It tends to move in this direction, friction will act in this direction. If the block were tending to move downward, friction would act upward, but the block is tending to move in this direction if the surface is smooth. So friction will act opposite to the direction. Okay. Now, but what is the limiting value of the friction? Mu times n. And n is 20 Newton here. Mu is 1 by 4. 1 by 4 times 20, which is 5 Newton. So 5 Newton is my limiting value, Fl. And my external force is greater than 5 Newton. 10 root 2 is greater than 5 Newton. So it will start moving in this direction with an acceleration of 10 root 2 minus 5 by 1, which is 5 times of 2 root 2 minus 1 meters per second square. Is that clear, students?
Yes, sir.
Okay. Any doubts you have got? You want me to repeat anything? I'll go for the next situation. I'll tell you what the situation is now. Let us analyze the situation first, then we'll do the mathematics of it. Physical analysis, then mathematical analysis. I've got a block. It's a block of mass m or m naught. This wedge, this block, bigger block, is going towards right with an acceleration a. All right. Coefficient of friction over here is mu. Let's say there is no friction here. There's only friction here. This is very smooth, and then this is a frictional surface. This is frictionless surface. All right. Let us say like that. Let us presume like that. We'll also solve it with when this has friction. There's no big deal. Once you have friction here, all you have to just add is friction component over there, a friction force over there. So let us presume there is no friction here and there's friction here. Next, we'll go for friction on both the surfaces. That's pretty simple. If you understand this one, that is very easy. I mean, there is no big deal in it. In the second case, where you have friction on both the surfaces. But in this case, I'm presuming here you have friction mu not equal to 0. Here mu is equal to 0. All right. Now the question is, find the acceleration for which the blocks will remain at rest with respect to the wedge. All right. We have to determine the acceleration for which the blocks will remain at rest. I'll rephrase the question. We have to determine the range of accelerations for which the blocks will remain at rest. See, I'm telling you range. All right. Even in the wedge case, we had a range of accelerations for which the block will be at rest. If you remember, if this goes with an acceleration A, pseudo force is leftward. So this will tend to slip downward, tend to slip upward. So there is a range of accelerations. Friction will flip its direction. So there is a range of acceleration for which the block will remain at rest. So here, what is the range of acceleration? Range of acceleration for which the blocks will remain at rest with respect to the wedge. So why do you say range? Like why do you have a minimum and maximum value? Or why do you have two values between which the block will remain at rest? Let's see. Whenever you have an accelerated reference frame, it is easier to solve it using the accelerated reference frame. So let's say I stand on this frame and draw the ability of the blocks. and go ahead. But before drawing that, what is the direction of friction if there is no acceleration? If A is equal to 0, what is the direction of friction, students? Simple. You think everything is smooth, so it is tend to see in which direction it's tending to slip. If it is tending to slip rightward, friction will be leftward. If it is tending to slip leftward, friction will be rightward. Right? So I'll presume the surfaces are smooth. If the surfaces are smooth, this will come down, this will go towards right. So this block will have a tendency to move towards right. So friction will act towards left. Is that reason okay?
Yes, sir.
Mhm. Okay. Others, is it okay?
Yes, sir.
Okay, Ashrita and Gayatri are listening, but others, I don't know whether you're listening or not. Okay, Likita is answering.
Yes, sir.
Okay, Hashni is here. All right, thank you all. Okay, look at this now. Now what happens with respect, now if there is acceleration is non-zero, it's accelerating towards right. With respect to this frame, I'll have an additional force of pseudo force which is Fp, ma towards left. So on this block, m naught, I'll have a pseudo force Fp, tension this way, friction this way. Now, because if acceleration changes, if acceleration was zero, my friction is towards left because it's tending to slip downward. All right. Now, what will I do? I'll hypothetically presume that it's at scenarios like this. Right? Any Puri problem, we have done it this way itself. If you remember, I'll presume it's horizontal and I'll say supporting force minus opposing force is the acceleration. So, what happens now is friction is towards left, but because of the pseudo force, if the pseudo force goes on increasing, friction will self-adjust so as to counterbalance the net external force. If pseudo force is equal to m naught g, my friction becomes zero. If pseudo force is greater than m naught g, my friction will flip its direction, become towards right, turn towards right. So this Fp is deciding what my value and direction of friction is. And what is Fp? Pseudo force, which is dependent on acceleration of the reference frame. So m times a or m naught times a, if it is very huge, that means it will have a tendency to slip leftward. Friction will be rightward. If it is zero, it has a tendency to slip down rightward. So friction will be leftward. So as long as the friction is self-adjusting, static friction, the block doesn't move. I mean, as long as the external force is less than limiting friction, the block doesn't move. And the limiting friction is mu times m naught g. So when limiting friction is acting towards left, all right, when the limiting friction is acting towards left, and let's say the acceleration is zero, it will have a tendency to slip rightward, friction will be acting leftward. Now it will definitely move because m naught g is greater than mu mg. Right? M naught g is greater than mu mg, it will definitely move. Mu is less than 1 in this case. Has it given? Okay, I'm not given, right? So mu is less than 1, let's. So it will definitely move. So acceleration 0, it's going to move towards right. But then, okay, we'll also consider the case for general case when mu is greater than 0. It's not less than 1, but it's a general case from 0 to infinity. All right, in general, mu is from 0 to infinity. All right, we'll also consider the general case, but for today, we'll just talk about the case when mu is less than 1. When mu is less than 1, block will tend to move towards right when the acceleration is 0. Why do I say that? Because external force over here is m naught g. Supporting force is m naught g. Opposing force is mu mg. Mu is less than 1. So this is less than 1. So net force is towards right. All right. So it will have an acceleration towards right. So it's slipped rightward. But now if there is this acceleration, pseudo force will act towards left, Fp, because of which net force on this blocks will be altered. Now, if this is Fp, m naught g, if this increases, net force will be now reduced towards right. Net force was right towards right initially. Net force will reduce and can become zero at certain value of Fp. My friction will self-adjust to counterbalance the net force, net external force. When this becomes zero, my friction also becomes zero. When this beats m naught g, my friction will turn direction, flip, and turn towards right. Did I confuse you or convince you?
Sir, can you repeat it?
Yeah, sure. That's good. Surely. Okay. Look at this. I've got a block like this, 1 kg, 2 kg. What is the acceleration of the blocks? What do I do? 2g minus 1g by 3. So g by 3 is the acceleration. That's what I write, right? How am I writing this one? I'm presuming this to be horizontal. I mean, hypothetically, treating this to be horizontal. This is 2g, this is 1g. 2g minus 1g by total mass. That's what I'm doing, right?
Yes, sir.
Similarly, I'll do the same thing over here. I'll draw the smaller block m naught on the table like this. I'll straighten the vertical block. So supporting force will be m naught g, which is m naught g here. And opposing force over here is friction, which is mu mg. Because mu is less than 1, it will definitely shift towards right because mu mg is less than mg. So it will go towards right. Is it okay?
Yes, sir.
Now, because they are moving together, I can treat this as one block. Because they are moving together with the same acceleration hypothetically on this straight horizontal level, I can treat them as one block. రెండింటిని ఒకటిలాగా ట్రీట్ చేయొచ్చు కదా m0 ని 2m లాగా ట్రీట్ చేయొచ్చు.
Yes, sir.
Now, when there is an acceleration, there is a pseudo force on it. Pseudo force ఎలా ఉంది? ఈ డైరెక్షన్ లో ఉంది. దీని మీద లెఫ్ట్ వర్డ్ ఉంది, దీని మీద లెఫ్ట్ వర్డ్ ఉంది. m0 into a ఉంటుంది, m0 into a ఉంటుంది. But look at this. Is this pseudo force supporting or opposing? No. This is counterbalanced by normal reaction. అందుకే ఇక్కడ దీని కింద సూడో ఫోర్స్ నేను డ్రా చేయలేదు. దీని మీద కూడా సూడో ఫోర్స్ ఉంది, బట్ హైపోథెటికల్లీ స్ట్రైటన్ చేసినప్పుడు ఈ pseudo force is neither supporting nor opposing. It is being counterbalanced by normal reaction. So I'm not talking about the pseudo force because that is neither supporting the motion nor opposing the motion. Now this pseudo force, which is m times a naught, this minus mg, m a naught minus g, or m m naught a minus m naught g is the net external force now. ఇప్పుడు ఇది ఇంక్రీజ్ చేస్తుంటే నా నెట్ ఫోర్స్ విల్ బి రిడ్యూస్డ్, రైట్? Initially when this is a is 0, net force is towards right, m naught g is towards right, net external force is towards right, అందుకే friction is towards left. As I increase this one, this force will reduce, the length decrease అవుతూనే ఉంటుంది, డిక్రీజ్ అవుతూ 0 అయిపోతుంది. When ma is greater than mg, net force will reverse. When this reverses, my frictional direction will reverse.
Yes, sir. I understood.
Okay, good. Now let's write the equations for this now. So I've got Fp, which is m naught a minus mg.
గ్రీజర్ వేసినావా మమ్మీ? ఎవరు వేసిర్రు?
Please mute yourself. All right, so you've got ma naught minus mg, ma naught plus friction minus mg equal to 0. So friction is equal to mg minus m naught a, m naught g minus m naught a. if this is less than limiting, which is mu times m naught g, I'll get the acceleration. So acceleration m naught gets cancelled out. A is less than or equal to mu g times, so g minus mu g. So A is less than or equal to g into 1 minus mu. So A is between 0. All right. So this is it. Now this is the acceleration for which. All right. Hold on. Look at, don't talk about the inequality right now. Now this is the acceleration for which the friction force is limiting. All right. Students will continue with this problem tomorrow with having friction on both the surfaces and also having a general value of coefficient of friction between 0 and infinity. All right. That's a more general case, which we'll do it tomorrow. But for today, you just understand when the force is limiting, friction force is limiting, this is tending to move towards right. That means net force on it is ma naught, mg minus ma naught. When it is moving, tending to move towards right, mg minus ma naught is equal to mu mg. When it is tending to move towards left, m naught a prime minus g mg should be equal to look at these two equations, students. This is the equation when the block is tending to move towards left. Sorry, towards right. Towards right. But this is the equation when the block is tending to move towards left. M naught A minus mg should be equal to mu mg here. But here mg minus m naught A, m naught g minus m naught A is equal to mu m naught g. All right, you'll understand this equation better tomorrow. I'll describe this. It'll take another few minutes for me to explain these two equations and why you have a range over here. All right, so you'll have a range of accelerations, and one of them will be minimum acceleration, the other will be a maximum acceleration. All right, so you'll have a range of acceleration for which the particle will be at rest. That we'll understand tomorrow. For as of now, if you have got any doubts in this scenario, please ask me. If you haven't understood this, that's okay. I'll repeat the whole problem tomorrow again with a more general case. All right, if you have understood, that's great. We'll stop the class here. Have you all understood, students?
Yes, sir. Sir,
Yes, sir.
Yes, someone is asking something.
sir, please explain that first equation, sir.
This equation,
Up, sir.
this one.
Yes, sir.
Yeah, sure. Yeah, these two equations we'll deal with it tomorrow. But this equation I'll explain you right now. I've got a pseudo force m naught a towards left. All right, because block is tending to move towards right, my friction is towards left, and m naught g is towards right. All right, so m naught g is towards right, friction is towards left, and m naught a is towards left. In fact, this is like this. No friction on this block, friction only on this block. M naught g acting on this one, m naught g not a supporting force on this one. So m naught g is equal to ma plus f. So ma plus f minus mg is equal to 0. Particle is at rest. Particle is in equilibrium. Net force is equal to 0. Net force is equal to mass into acceleration. Acceleration of the particle with respect to the reference frame is 0. I am solving this with respect to the non-initial reference frame, accelerated reference frame. All right. So m naught a plus f, both are in leftward direction, minus m naught g, rightward direction, is equal to 0. All right, I'm just adding all the forces. ఈ టూ ఫోర్సెస్ లెఫ్ట్ వర్డ్ ఉన్నాయి, ఈ ఒక ఫోర్స్ రైట్ వర్డ్ ఉంది. So if I take left as positive, this plus this minus this is equal to 0. Is it okay, Likita?
Okay, sir. Thank you, sir.
Most welcome. All right, let's stop here, students. Have a great day. See you in the evening. Bye, everyone.